was not just the US restrictions. 36 Chinese semiconductor companies terminated their IPO reviews in the first half of 2024. That's nearly equal to the total number of IPO terminations in 2023. 10,900 semiconductor-related companies deregistered in 2023, at the rate of around 30 companies per day. Add that to 10,000 Chinese chip-related companies that already shut down in 2021, 2022. In 2020 alone, 50,000 semiconductor-related companies were registered. What happened to those companies? We had covered some of the Chinese semiconductor debacles before 2022 in an earlier video in this channel. Here is an extract from that. Over the past 3 years, at least 6 new major chip-building projects, including HSMC and QXIC, have failed in China. At least $2.3 billion went into these projects, much of it coming from governments. Some never produced a single chip. That was from a report in the Wall Street Journal in January 2022. Hello and welcome to Strategy TLDR, a channel where we explain strategy concepts important for managing your business. In this episode, we explain why China still lags in advanced computer chips manufacture, despite a determined national effort for nearly a decade. The opening remarks you heard at the top of the episode were from various reports from 2023 and 2024, and are the Wall Street Journal report from 2022. The Chinese semiconductor industry regularly serves up such headline-grabbing news. 2 more examples are a collaboration between Global Foundries and Chengdu Province ended in failure, and the Wuhan Hongxin Semiconductor project was exposed as a scam. How much has China invested in this sector? China's government has poured over $100 billion into this sector over the years. It recently added some $47.5 billion into its Big Fund 3, which is also the 3rd phase of its National Integrated Circuit Industry Investment Fund. Add to that similar funds set up by local governments and their investments and incentives. According to Yole Group, a consulting firm that specializes in the semiconductor industry and adjacent industries, mainland China has growth plans worth $143 billion up to 2025. The questions that are often asked are, despite the 100s of billions of dollars poured into this sector, why China has not made advanced semiconductor chips yet? Why are Chinese chip makers struggling again and again? Why could China not build advanced semiconductor manufacturing capabilities in 10 years with all those billions? We will answer the questions at a fundamental level. It will help you understand the strategic business constraints based on which geopolitical strategies and tactics have been developed in this industry. But before that, what has China to show for these billions of dollars of investments? These points have been compiled based on reports from Japan, Korea, and Taiwan. Some of them do refer to Chinese research publications. 1. Locally made Chinese CPUs, the main computer processors, released in 2024, are only as powerful as Intel and AMD chips from 2018. Used. 2. China's domestic chip-making tool manufacturers only have a production rate of 1% of the critically important photolithography tools. This hurts advanced chip manufacturing. 3. Since there are restrictions on access to the latest semiconductor production technology, China's SMIC has to rely on an older technology called DUV, or deep ultraviolet lithography. These require more production steps that increase the costs and the likelihood of defects and further straining production capacities. Huawei did mass-produce 7 nanometers chips using the older technologies the country has. 4. Because of the difficulty in importing NVIDIA's or other competing AI GPUs, Chinese firms like Baidu and Alibaba have started using multi-chip hybrid technologies that would allow them to combine different chips into a single training cluster. 5. It is reported that SMIC lacks sufficient engineers to manage and maintain its semiconductor machinery. Reportedly, it poached many from Taiwan, but then Taiwan has made that illegal. Before we dive deeper, here is a simplified lay of the land in semiconductor manufacturing. This will be useful in understanding the subsequent discussions. If you already know these, you can skip to the next segment. Semiconductor industry is not like meat processing, where animals arrive at one end of the factory, and after initial processing are cut into smaller pieces, packed and shipped. The semiconductor industry is much more complicated. Only a few firms do integrated design and manufacture, IDM. As we see below, many well-known firms simply specialize in just one part of the industry value chain. As the Semicon Society explains in its website, there are three main segments: wafer fabrication, assembly and testing, and design and development. The global strategy consultancy, Bain & Company, in its report highlights the different business models in this industry: fabless, foundry, or integrated business model. Companies like NVIDIA do not have fabrication facilities or fabs. They only design their chips. TSMC, Samsung, Global Foundries, etc. have foundries. And there are companies like Intel that have an integrated business model which starts with own designs that they can fabricate in their own facilities and have testing and packaging facilities. From a product perspective, semiconductors can also be categorized as memory chips, microprocessors, and integrated chips. Other commonly used semiconductor product terms you will come across are central processing units, CPUs, and graphics processing unit, used GPU. For some simple explanations of what they are and what they do, please refer to Wikipedia, Investopedia, or other reliable sources. The Intels and TSMCs of the world will also need advanced materials, specialized innovative manufacturing and testing equipment, secret processing techniques that they have fine-tuned over many years to get high process efficiency and high yields for the chips they make. There are a few companies that are world leaders, each in these areas. Here is where new entrants like China face challenges. As the Bain report pointed out, each of these require foundational IP and ongoing innovation, as well as the engineering talent to sustain it. These factors are self-reinforcing, which is great for market leaders, but makes entry difficult, even for the most well-funded challengers. Take, for example, the EUV lithography machines from the Dutch company ASML that Intel started installing in early 2024. It reportedly cost $380 million and weighed about 150 tons. It is not just expensive and massive, it will also take 250 ASML and Intel engineers about 6 months to install the machine completely. The job will not be over for these engineers with installation. They will then have to work together for months to calibrate it and achieve the desired yields. What is EUV, did you ask? EUV is an advanced type of photolithography that uses extreme ultraviolet light to create intricate patterns on silicon wafers. This has enabled the industry leaders, TSMC, Samsung Foundry, and Intel, which use EUV lithography tools to make advanced semiconductor chips. So, what is China's constraint in building advanced semiconductor manufacturing capability? In business strategy, this challenge faced by China is called path dependency in creating capabilities. In simple words, it means, to create a particular capability, a firm must go through a long, difficult learning curve. There is no shortcut to the learning process. New firms must go through the experiences to develop the capabilities. For more details, refer to How Firms' Capabilities Affect Boundary Decisions by J. Barney, MIT Sloan Management Review, Spring 1999. What this implies for semiconductor chip manufacture is that there is no shortcut for China to take. The top semiconductor foundries like TSMC and Samsung have invested a lot in developing the cutting-edge manufacturing process technology. They have acquired intellectual property by investing billions of dollars in R&D. So they are not going to teach or share the IP with competitors. The same applies to Intel and other US companies. How did China's SMIC and other companies in that country get the technology to make the previous generation chips and processors? US and European semiconductor firms were investing in China for semiconductor manufacturing. They were exporting and transferring required technologies, manufacturing equipment, chemicals, and the like to China. Of course, that was for making older generation chips. One of the boons of cutting-edge technology is that current manufacturing equipment and their accompanying technology helps newbies to come to speed even if the industry leaders do not want them to learn those techniques. This was very well explained in the article, Why High-Tech Commoditization is Accelerating, by Willie Shih in MIT Sloan Management Review, Summer 2018. Key points he made in the article are 1. Knowledge embedded within state-of-the-art production and design tools is a powerful force that is leveling the global technology playing field. 2. Advanced production tools commoditize the manufacture of many hardware products, making differentiation more difficult. 3. Modern computerized design and simulation tools reduce the value of experience. Chinese companies like SMIC benefited from this and were learning to make next-generation chips faster. This is how Huawei SMIC managed to make 7 nanometers chip, reportedly by tweaking older DUV lithography machines, though not with good yield. They did not have the access to the latest EUV machines from ASML, which are used by TSMC and others, but over the years US has progressively restricted American companies from investing in China in this area. It is concerned not only with China's technological advancement as a competitor, but also the civilian and military dual use these technologies have. From a geopolitical standpoint, that is a huge concern for the US. So it has restricted advanced semiconductor chips, components, raw material, equipment, technologies, and services from being exported by US companies to China. It has incentivized Intel, TSMC, Samsung, and others to open manufacturing facilities in the US. Other leading semiconductor manufacturers are also investing more in Southeast Asia, Europe, and other regions friendlier to the US. In addition, it has leaned on its geopolitical allies, like NATO countries, Japan, and Taiwan, that make cutting-edge semiconductor manufacturing equipment, tools, and chemicals to restrict their companies from exporting their latest products to China. We saw earlier that EUV photolithography machines, and even advanced DUV machines, both made by the Dutch company ASML, that enable the manufacture of 7 nanometers and smaller chips, are not allowed to be exported to China. Going beyond restricting investment and sales, it is now pressurizing ASML not to service the older machines that it had installed in China in the past. It has already placed similar restrictions on US citizens and green card holders from assisting chip development and manufacturing in China. This helps us understand why US efforts to restrict sale and service of advanced design and production equipment from anywhere in the world to China is a strategically important move. Using the accompanying semiconductor industry business model, one can see that US has placed restrictions on most players in the industry around the world from doing business with China. On top of that, raw material and equipment suppliers, as well as highly skilled and difficult to find industry talent, are also now prevented from doing business with China. It has also persuaded its allies to do the same. Reports had indicated that China poached over 3,000 Taiwanese engineers to develop its semiconductor industry. They made up nearly 10% of China's workforce in that industry. But Taiwan's labor ministry then banned recruitment companies from hiring for jobs in China. Obviously, it was an attempt to prevent semiconductor specialists from migrating to China. These restrictive moves by US and its allies have hurt advanced semiconductor research and manufacturing in China. To learn to manufacture cutting-edge semiconductor chips, China now cannot easily acquire the latest manufacturing equipment, raw material, and talent, as it had in the past, to catch up with the leaders. Exactly as the path dependency concept predicts, to create these capabilities, Chinese firms must go through the challenging experiences of developing on their own the technologies for every value-adding step in the industry, for every specialized raw material, and advanced manufacturing equipment must develop their own processes, and then experiment with pilot manufacturing before scaling them up. After that, they have to work on improving the yield of each of the advanced chips before going to the next smaller one and repeating the processes all over again. This is what the industry leaders like TSMC, Samsung, Intel, ASML, and others did over many years. And that is a long, difficult learning curve. Given the level of specialization in each part of the industry, there is a whole mutually dependent ecosystem in which it operates. Currently, neither America nor Europe or East Asia have complete ecosystems within their shores. Different regions and countries have IP in different cutting-edge technologies. When America and its allies are working together to restrict China acquiring their technologies, that country has to develop that complete advanced ecosystem within its shores. And that will take time. Thanks for watching the episode till the end. Hope you understood the fundamental strategy concepts based on which the business and political strategies and tactics are developed and executed, and their impact on the global semiconductor industry. I'm sure that you can understand now why, as China tries to catch up with 7 nanometers chip production, TSMC and Samsung are racing ahead with more advanced 5 and 3 nanometers chips. The links to the articles and news items are in the show notes. Please share the episode and subscribe to the channel.